All right, let's do this function here, this rational function. First thing we need to do is we need to factor this. And so, looking at this equation here, the bottom, we're looking for two numbers that add to, let's see, add to -8 and multiply to 15. So that's going to be x minus 3 and x minus 5. Now up top, we need, we can do this with the AC method, or we might realize that we're going to have x and 2x here. And we know we need two numbers that multiply to 15. And I'm going to hope that these two numbers are 3 and 5. Because if they're 3 and 5, that's going to work real nice here. Okay, and with a little bit of looking around, we see that they are 3 and 5. And this is going to be a -3, because if you distribute this out, if this is -3, you'll have -3 times 2x, that's -6x. And when you distribute this out, you'll have x times 5, and that's 5x. So -6 and 5x add to -1x. They work out nicely. And these will end up canceling here. So it does simplify to 2x plus 5 all over x minus 5. Okay, so we've got our factored form there. Okay, we did that there. Okay, the domain is all the numbers that do not make the denominator 0. And what makes the denominator 0 is a 3 and a 5. Okay, so 3 and 5 make the denominator 0, so it can't be that. So our domains are going to be from -infinity all the way up to 3. We're going to have a gap at 3. We're going to go up to 5. We're going to have another break. Oops. Let's get that out of there. We need a union. And from 5 to infinity. Like that. Now we need to find the roots or the zeros of this function. The zeros come from the numerator.
Sorry, I'm having trouble with the connection.
So we need to find out what makes the numerator 0 there. And so we have, well, x minus 3 times 2x plus 5. That is our numerator. What makes it 0? Well, 3 makes the first part 0. So x equals 3 is 1. What makes 2x plus 5 equal to 0? Well, if 2x plus 5 equals 0, then 2x equals -5 divided by 2 divided by 2. X equals -5 halves. All right, so there is our only 0. We've got to actually throw this one out because that's a domain restriction. So x equals -5 halves is our only 0. Now vertical asymptotes, that comes from the numbers that don't get canceled out here, and that is 5. Okay, the 5 that does get canceled out, that is going to be our asymptote. Okay, the 3 got removed, so that's going to be a hole. I'll make a note of that. There's a hole at x equals 3 because that discontinuity, that break, that problem gets canceled out. But the thing that doesn't cancel out is 5, so it's still there. All right. Horizontal asymptotes. Well, horizontal asymptotes come from this. If we take the simplified version, the 2x plus 5 over x minus, what was it? 5, right? Yeah. Okay. X minus 5. So if you took that and you divided it out, 2x plus 5 divided by x minus 5, well, this is 2. 2 times this is 2x minus 10, and we subtract, and that's 5 minus -10, and that's 15. That's our remainder, okay? That's our remainder. But this right here is our horizontal asymptote. The shortcut is this also. If we take the coefficients 2 and, let's see, 2 and 1, that's funky. Anyways, 2 and 1 there that I just covered up. Those are 2 over 1. That is the horizontal asymptote. Okay, so the horizontal asymptote, okay, is, see if I can spell. All right, it is y equals 2. Comes from that division, or just comes from the shortcut. The shortcut only works, by the way, when these coefficients, or these degrees are the same on the top and the bottom. All right, let's graph this up and be done with it. First thing you want to graph is your asymptotes, all right? So we have asymptotes, horizontal asymptote at y equals 2, and a vertical asymptote at x equals 5. So there's our vertical asymptote at x equals 5, and our horizontal asymptote there at y equals 2, right there. All right, now we got to find the graph of this. Let's go for the zeros. We have the zeros over here. We had 1, 0 at x equals -5/2. So let's graph that one down here. -5/2 for an x-intercept is about right here. That's our 0. That's the only place it's going to cross this. Now we can also find the y-intercept. That's a useful point. So let's go back up here. The y-intercept is when x is 0. So if x is 0, all of these become 0. X is 0, x is 0, x is 0, x is 0. And those things just get wiped out. Okay? And so those are wiped out. And when those get wiped out, we're left with a -15 over +15. And that is a y-intercept of -15 over 15 is -1. That's our y-intercept. So let's graph that y-intercept here. Y-intercept of -1. There it is, and that's enough to plot this. Looks something like that. Okay, now over here we got to decide if the graph is up top or if the graph is down here. Now, most likely it's going to be up top because we don't have any more x-intercepts. Okay, but just to make sure, plug a point in like 6. 6 is an x value here that's outside, so let's plug that in. You can plug it into either one of these. Let's go ahead and plug it in the simple one. 2 times 6 plus 5 all over 6 minus 5. Well, that's going to be 12 plus 5 is 17 on top over 1. So 6 is 17. Well, that's the point 617. That's way up here off the charts, okay? So that is going to be good enough. We might want to plug in another point because we've got this weird curve somewhere out here. Maybe let's try 10 real quick. Just to get a feeling for where the graph is, if x is 10, we have 2 times 10 plus 5 all over 10 minus 5. And that is 20 plus 5, that's 25 over 5, which is 5, right? So when x is 10, y is 5. And so 10, 5, we get right here, all right? And so it's going to be something like this. It's going to shoot up pretty fast there. There's the graph. Last thing we got to watch out for is the hole. And we have a hole at x equals 3 here. That was the factor that canceled out. It's removable. So go find where x equals 3. And we're going to put a dot at x equals 3 on that. If you can erase it. Mine won't erase because it's stuck like glue. But just put an open dot there. All right, that shows that point doesn't really exist. Okay, there's your graph. Good luck. So, well, first of all, find the asymptotes. Graph those first. Graph the x-intercept. Graph the y-intercept. Plot the points or plot the curve, and then find another point on the other side and get that curve. Last but not least, make sure you put the hole in. All right, good luck.